So this is the solution to the first one. 4ab minus 2a plus a minus b over negative 10. All you do is you substitute the value for negative 7 wherever you see an a, and you put in 3 wherever you see a b. All you need to do is plug those values in and then simplify. That's all it takes to do the first problem. So now that I've started using this method of solving before explaining, I hope that you can take some time to write out the solutions and then follow me step by step. Step 1, we've plugged in all our values for a and b. Step 2, we go ahead and simplify. Negative 4 times negative 7 times 3 would give us 84. So that's what I show you there. Now, negative 2 times negative 7 is plus 14 because a minus times a minus is a plus. Negative 7 minus 7 minus 3 over minus 10 would give you minus 10 over minus 10, and 10 over 10 or minus 10 over minus 10 is equal to 1. So 84 plus 14 plus 1 is equal to 99. If you did it using 2b, negative 2b, you should get 79. That's how you solve number 1. Any questions on number 1? Okay, number 2. It's a little more intense, but let's step aside for a second and look at the simplified version. The simplified version is where I would basically take the first bracket with the exponent and I will simplify that to m minus 5 and then minus 2, which will become m to the 10th power. That's all you need to do. You take it step by step. That's what math is about, learning how to take things step by step. And once you have a solid foundation, everything else will make sense. Step 1 of what I did was to simplify all the brackets that were involved and the exponents. That gives us m to the negative 5 times minus 2, and then n to the negative 6 times minus 3, and then m to negative 9 times minus 2, and then m to 7 times 3. Now, this is supposed to be an n as I showed you in this step. And so that we're not confused at this, because if this remains an m, our answer will be different. So we're going to leave that as an n. So n 7 times 3. What's 7 times 3? 21, right? And that becomes n to the 21. So this is where we get n to the 21. Because this is an n, not an m. So n to the 21st power. Now we simplify all of the things that have the same base. So m, and m, meaning that now we can add the exponents because they are multiplying one another. So it's m to minus 7 plus 10 and then plus minus 3. But a plus times a minus will give you a minus. And so let me show you something here. So that you're not confused again, this is an n. And when we go ahead and simplify all our values, we have our m's together, and then we have our n's also dealing with, like, so n to the minus 2 and then n here to the 18th power. Minus 2 plus 18 would be 16. And so I went ahead and simplified, and step by step, I'm hoping that as you look through the correction, it will make more sense. When we get m to the minus 7 plus 10 minus 3, that is the same thing as m to the 10, negative 10 plus 10, which gives us m to the 0. Anything to the power 0 is a 1. And so essentially, that's why the m kind of disappears. It becomes a 1 and it goes away. For the n, we have n to the 16th power, and that's the same thing. And then on the bottom, we have m to the 18th, and then n to the power negative 9 plus 21, which is m to the 18th, n to the 12th power. Because they share the same base, n and n, we can bring this 12 to the top so that it becomes n to the 16th minus 12. And so this becomes n to the 4th power, while the m to the 18 remains what it is. Let's say, for example, you kept solving and you left your m to the 0. What that means is that you would have m to the 0 minus 18, and then n to the 16 minus 12. This is then equal to m to the power negative 18, n to the 4th power. That is one way the simplification can go. But we don't want negative exponents at the end of the solution, at the end of the problem. So what we do is we rewrite it. And according to one of the laws of exponents and indices, when something is to the power negative, when it has a negative power, you have the right to rewrite it as 1 over that number to the positive exponent of that number. And so it's 1 over m to the 18 and times n to the 4th power, which is the same thing as n to the 4th power over m to the 18th. If it doesn't make sense at first, just write out the solutions, do the practice, and it should start making sense. I'll give you another problem tomorrow and we'll go from there. Any questions? Yes?
Could you simplify it n to the second m to the 9 over m to the n to the second over n to the 9?
Can I simplify this? No, because they don't share the same base.
Oh.
What this is the same thing as saying n times n times n times n over m times m all the way to 18 m's. N's don't go into m's and m's don't go into n's. If I gave you specific numbers, then yes, maybe you'll be able to simplify.